Okay, we're about 25 minutes into the demonstration. We've incorporated about 2.5 inches, maybe a little bit more water. And as you can look down through here, the root zone mix is almost completely hydrated. And what we're going to do now is this water is going to begin to hit this interface. You know, this barrier, this line right here, that's a barrier for water movement in a soil. And that's why this bridging gravel needs to be of a diameter where it keeps that fine particles from migrating down into this drainage gravel. But it's also important that the average diameters in here match up with the larger diameters in there, so that this is less of an impedance to drainage. So this is really an important aspect right here. That is really critical how we construct that, because if we get a 2-inch rainstorm, we're going to infiltrate that water into the root zone mix, but it is not going to leave. It's going to be totally available to the trees or to the lawn to utilize that water. It is not until we exceed the field capacity of this root zone mix. And what's the field capacity? That's the pore space that exists. And when the water totally fills all of the pore space, then we've reached field capacity. So at that point, there is no more openings for water to fill up. You know, water is totally filled, every void. And once that happens, then it begins to drain from this root zone mix into this bridging gravel. And we'll actually see it move down into the drainage gravel shortly thereafter.